Hello everybody, welcome to a new video of my channel Physics with Argel. Today we are going to solve the problem 38 of the book Physics Concepts and Applications of the very respected and excellent Professor Paul E. Tippens of the Department of Physics in Jefferson. The problem is this: two charges attract each other with a force of 6 multiplying 10 raised to the power of -5 Newton, when they are some distance apart in vacuum. If their separation is decreased by a third of its original distance, what is the new force of attraction? I have to use the law of Coulomb, but this law establishes that the electrical force F is equal to the constant of Coulomb K multiplying the product of the two charges Q sub 1 multiplying Q sub 2 divided by the distance between these two electrical charges R raised to the power of 2. But the new distance is 1/3 part of the original distance R, so R over 3. I'm going to call it R primed. So R primed equal to 1/3 of R, equal to R over 3. It implies that R primed squared equal to 1/3 of R squared, equal to R primed over 9. So this is the new square of the new distance. So the new law of Coulomb, or the new force F primed, equal to the constant of Coulomb K multiplying the product of the two electrical charges Q sub 1 and Q sub 2 divided by R squared over 9, equal to K multiplying Q sub 1 Q sub 2 over 1 closed in parentheses over R squared over 9 closed in parentheses, equal to K multiplying 9 times Q sub 1 Q sub 2 over R, equal to 9 times multiplying K multiplying Q sub 1 Q sub 2 over R squared. But this expression closed of red is the original force. So it's equal to 9 multiplying K Q sub 1 Q sub 2 over R squared, equal to 9 times F. But F has a magnitude of 6 multiplying 10 raised to the power of -5 Newton. So equal to 9 multiplying 6 multiplying 10 raised to the power of -5 Newton, equal to 54 multiplying 10 raised to the power of -5 Newton. Now I'm going to resolve an extra example. Let's suppose that the force equal to the constant of Coulomb K multiplying Q sub 1 multiplying Q sub 2 divided by R squared. Giving magnitude to the charges, it's equal to 9 multiplying 10 raised to the power of 9 Newton meters squared divided by Coulomb squared multiplying 1 Coulomb multiplying 1 Coulomb divided by 1 meter squared. 1 Coulomb multiplying 1 Coulomb squared divided by Coulomb squared equal 1, and 1 meter squared dividing meter squared equal 1. So equal to 9 multiplying 10 raised to the power of 9 Newton. But now let's suppose the original distance is multiplied by the factor 1/3. So the new distance is r/3. Now I'm going to calculate the new electrical force F prime at this new distance, being 1/3 of the original distance. So F prime equal to K multiplying Q sub 1 multiplying Q sub 2 divided by r/3 squared equal to 9 multiplying 10 raised to the 9th power multiplying Newton meter squared over Coulomb squared multiplying the magnitudes of the electrical charges 1 Coulomb multiplying 1 Coulomb divided by the new distance of separation. But r was 1 meter, so r/3 equal to 1/3 of meter raised to the power of 2. This is equal to 9 multiplying 10 raised to the 9th power of Newton's meter squared over Coulomb squared multiplying 1 Coulomb multiplying 1 Coulomb 1 Coulomb squared divided by 1/9 of meter squared. Now, put a lot of attention in this 9 of red, because this 9 dividing will be multiplying. So 9 multiplying 9 multiplying 10 raised to the power of 9 Newton meter squared over Coulomb squared and Coulomb squared divided by meter squared equal to the next. Coulomb squared divided by Coulomb squared equal 1. Meter squared divided by meter squared equal 1. 9 multiplying 9, 81. Multiplying 10 raised to the power of 9, Newton. So this means the next. The last force I've calculated is F prime. But the first force I calculated was F. So F prime divided by F equal to 81 multiplying 10 raised to the power of 9 Newton divided by 9 multiplying 10 raised to the power of 9 Newton equal to 9. This means that F prime equal to 9 times F. So the new force F prime is equal to 9 times bigger than the original electrical force. This means that if the distance is reduced to a third part of the original distance, then the consequence is that the electrical force will be 9 times bigger, because the Coulomb's law establishes the next. The magnitude of the electrostatic force F between 2-point charges Q sub 1 and Q sub 2 is directly proportional to the product of the magnitudes of charges and inversely proportional to the square of the distance between them. So this means that if the distance is shortened to a third part of the original distance, then the force will increase in a factor of the square of this number. Students, it was the problem 38 of the book Physics, Concepts and Applications of the very respected and excellent Professor Paul E. Tippens of the Department of Physics in Chairperson. Thank you for your attention. In the next video, I'm going to resolve another problem and study a lot.